very sorry that I can't attend the meeting in person, but I hope that you like this talk. Um, um, my name is Xintao. You can find me in Twitter and GitHub using this ID. And I'm an SRE. As an SRE, I receive a lot of alerts, and I don't like them. So today we will going to talk about how can we make them less annoying. We will talk about how to set up alert rules with confidence and how to fire alerts with more information and how to review alerts. Let's dive into the first part, how to set up alert rules with confidence. If you have ever set up alert rules, I think you will ask those questions to yourself. For example, did I use the syntax rules correctly? You don't want to break the whole alert rules configuration and just missing a column in the YAML. And is this threshold reasonable? How many times will my alert be fired every day? Will somebody be spammed by my alerts if the threshold was too low, or to be more worse, the alerts won't be fired if there's something going wrong because the threshold was too high. And who will receive this alert? And what if all of my alerts are all set, but later someone breaks them, just changing some labels and or thresholds? The answer to those questions is CI. Before we dive into CI, I need to explain that we use GitOps to manage all of our alert rules. The GitOps means that we put everything into a Git repository, everything about the monitoring observability. For example, the targets, the service discovery for Prometheus, and the alert rules, the alert routing in Alert Manager. The good thing about GitOps is that everything is in Git. You can check the changes in Git commit history. You can use Git clean command. And the revert rollback is very easy. And you can review the changes like you're reviewing the code. Everybody is very familiar with the pull request UI and the merge request UI. And CM will test everything for you. That's the main part of our today's topic. And there is no magic under the hood. Everything is in the code repository. If you want to know how is something works, you can just check the code. And in Git, you can use your favorite editor to edit everything. Yes, I mean Vim. The downside of using Git using GitOps is it's not very user friendly as web UI. Some company has a wrapper around the alerting rules. It's a web UI. You can just creating or editing existing alert rules by click some button, input some fields in the form. Then the system will converting the web UI into the alerting rules. But I always found that in the end, you need to how did the system work? How do they transform the input into the alert rules so that you can use the system very well? So in a way, it's not that user-friendly. And we can see that GitOps is also user-friendly. It's just very picky about who its friends. Let's see how the UI can how the CI can help you in setting up alerts. Let's talk about the first question. Did I use the syntax rules correctly? The answer to this question is the prom tool. Prom tool is the built-in tool in Prometheus. You can use the command prom tool check rules to check if all of the syntax is correct. And you can add this command into the CI. It works like this. Every time somebody opens a merge request, then the CI will run this command. If the syntax is correct, then the CI will successfully ended, return the code 0. And if there is something wrong, the CI will fail. And the prompt tool will tell you which line has which issue. The error message is very explicit. You can also test the syntax of alert manager using the AM tool check config. It works the same. And a more complicated example is this question: is this threshold reasonable, and how many times will my alerts be fired? If the threshold is too low, then there will be too many noises. If the threshold is too high, then we won't be noted if there is something going wrong. My idea is that when we can use the real world data to evaluate the alert rules. So it's implemented like this. When a merge request is open, this CI job will be triggered. Then the CI will firstly load in the alert rules from the source branch, which we made the changes. And then it will switch to the target branch with normally main branch and load the alert rules again. Then it has the two sets of alert rules. Then it can find the changed rules. Once it finds the changed rules, it will save the changed rules into a new Prometheus alert rules file, which only contains the changed rules. And then it will replay the changed rules against the production Prometheus. And then it will know that the changed rules, how many times will be those rules be fired alerts. Then it will report the result in the merge request by comment. It works like the code coverage bot. When you submit a pull request on GitHub, some projects, there will be a code coverage bot that seeing how many lines of code are changing and how many of them are covered by unit tests, right? It works the same way. Basically, whenever a rules was changed, you can see the past 7 days fire history. We found that the 7 days is normally enough. This pipeline is very easy to implement. Only one of the difficulty is the replaying part. For the replay, it works like this. It has 3 steps. The first step, read the history data from production Prometheus, and then evaluate the recording rules or alert rules against the real data, and then save the results for as new metrics. This feature in somewhere called rules backfilling. Here we focus on the alert rules. For alert rules replaying, the generated result was alerts with the labels as new metrics. If the alert if the alert should be fired, then the value is 1. If the alert was not being fired, and then the result will be null. So once the new generated alerts were being saved to temporary Prometheus in CI, and then we will read the result and then generate the report. There are 2 tools implemented this already. One is PromUtil script by CLI It's only 200 lines of code. It's very easy to understand. And another is VM alert by Victor Metrics. It's supported rules backfilling by default. This is also a very useful tool. The generated report is something like this. There are 3 columns in our implementation. The first column is firing times. the first column, sorry, the first column is the labels come with the alerts. The second column is the firing times when this alert should be was being fired. And the third column is where will this alert be sent to? We have the third column information using alert manager. Let's see how can we do this. Okay, there is a tool called AM tool that comes with alert manager, and it has a feature called root test. You can use it like this: AM tool dash alert manager URL and configure root test, and then you put all of the labels that you get from the alert replay. You can see that you need alert manager URL. We test this basically using the same way that for the alert replay. We start a temporary alert manager using the alert manager configuration in Git repository, and we tested the generated alerts with labels against this alert manager. And the second line is the output of the AM tool. It will tell you which channels will receive those alerts. Okay, the last but not least question: what if someone breaks your alert? The answer to this question is unit test. Unit test for Prometheus is like the unit test for code. Basically, you have alert rules, right? And you need to write the simulated data to test your rules. You write your data, and the alert should be fired or not, and then you use prom tool again. Prom tool test rules. If the alert rules fired your alerts as expected, then the unit test will be success. Otherwise, it will fail. Okay, finally, we have tested everything we can when a new change is made. And if everything works as expected, the CI will be green. And then we can review by peers. We can communicate in the comment. If everything is okay, then we merge the change. And the GitLab or GitHub CD will push the changes into production environment, and the alert rules will take effect. Then the next step is receiving the alerts or firing alerts. Imagine this: when you see this alert, what do you know? What's the question do you know the most? For me, when I see this text, I will wonder how bad is it, right? How high is the CPU usage now? I think that's the first question comes to everyone on call. If you see this message as an example, if you see this message, this picture, you will know that in our situation, I will know that our stress test team is running the stress test. They want to test the system's capacity using generated fake request. If the system is okay with the current QPS, they will increase the QPS until reach the system's capacity. So the stress test, the test team will focus on the dashboard closely, so they won't overloading the system. So if our SRE see the picture like this, the CPU increasing step by step, then normally it's created by a stress test team. You can verify it in the stress test platform, but usually this is the case. And there are other patterns of the known issues. For example, the first is the stress test, and the second one is not typical on CPU usage, but it's very typical on memory. Normally, when after a release or after a certain bug being triggered, the memory will increasing slowly and reach the threshold and finally be killed by our OM killer. Normally, there is there is a memory leak. We need to troubleshoot bug. The third image is either a DDoS attack or we have a real user traffic. Because some big seal, yeah, either situation we need to check it immediately. And the fourth image showing that the capacity is being reached. The QPS or CPU usage was reaching the threshold time by time. We need to scale up our system. So you can see that the alert chart is very useful when we receive the alerts, right? Let's have it. How can we get the image? It's very straightforward. You just query the metrics from the data source, from Grafana or Prometheus directly, and then you render the image, and then you send the alert with the image, right? The problem with this is when Prometheus evaluates your alert rules, if the result is null, then it means that everything is okay. Prometheus won't fire an alert. If the result is not null, then the alert should be fired. So if you just render the image using the alert rules from QL, you will get the image like this. The line sometimes has the line, sometimes it's blank. It looks like missing. This actually is not the worst image. Normally, the real alert rules, if you render it, it will be blank in the most part of the image, and it's only show very small part of the line when the alert being triggered, right? So what we need to do is that we split the PromQL alert rules into two parts. The one part is the expression. The second part is the threshold. So when we render this image, you can see the line and you can see the threshold, and you can see when the line and the threshold crossed. So I wrote a tool that called PromQL-PY. It can pass the PromQL into two parts, the expression and the threshold. And it can also pass the AND or operator. If the alert rules had AND, you can render it into two parts within two images. And then I wrote another tool called Matrix Render. Basically, it's a HTTP service, and you can get the rendered image using the HTTP URL, and you pass the expression, the alert fired time in the URL, and the data source name in the URL. Then you will get the image. Then you can add this image into your alert template. So that when alert fired, it will looks like this. Compared to our previous plain text alert, you will find this alert is much helpful. Okay, last but not least part, review alert with confidence. If we don't have the review process, we will have more and more alerts, and some of them will have too many noises, and the SRE will get familiar with the alerts. When we receive them, they will think, oh, that's okay, because it's not very severe, and you can just ignore this alert. You don't want the alert bothers everybody time by time, and if alert can be ignored, it shouldn't be fired at the first place, right? And so that we need to review the alerts. How can we do this? We need to have the information, right? We do this by alert manager. We actually create a reaction center, a system. Alert manager, we configure a route at the very beginning in alert manager. When an alert should be fired, alert manager send the alert using webhook to our reaction center first. Then alert manager will send alert to other channels based on the routing configuration. Our SRE or people on call receive this alert. It can interact the alert with in the reaction center with the other colleagues. We can acknowledge the alerts. We can comment on the alerts. We can make more reactions like mute the alerts or create Jira ticket to follow up the improvements. And when the resolved message, when some of the instance was resolved or fully resolved, the alert manager will send more information using this webhook, and the reaction center will append the timeline. And once we have those information, we can have the summary, the report of the MTTR of the alert acknowledge time and the alert recover time. So we can, and how many of the alerts were marked as noise, false alarm, and how many of them are real instant, so that we can tune our alert rules. The routing configuration that I mentioned is something like this. You just put the reaction system webhook into the first place, and you have to set the continue to true. So alert rules will continue to send the alert into other channels. That's the web UI of our reaction center. You can see people and the alert manager can interact with the event. Okay, that's all I want to share regarding the alert path. Thank you.